Hello, welcome back. In this segment, we're going to look at all of the remaining data types in Java, and we'll look at what it means to do arithmetic when you have variables in the expressions that are of different data types. I know that this one will look a little bit boring to you, and you're probably saying, oh no, is this a math class? But it's a good place to start. Get comfortable with all of the details of the primitive parts, and then we'll get on to some problem solving and some more interesting stuff. Really, I promise. Okay, so in the previous segment, we looked at two data types, int and double. And these are the most common data types for numeric variables in Java. If you're not using int and double to store your numbers, you're expected to have some reason why not. So there are 6 more primitive data types, so 8 altogether. And you need to know all of them and what range of values they can hold. And you also need to know when you write numbers in your program, or you write some constant values in your program, like the number 10, this is called a literal, or a literal constant. And the literal constants also have data types. I'm introducing here the concept that Java is a strongly typed language. So every variable has a data type, the literal constants have a data type, and the operators have data types. It's obvious that the variables have data types because you have to use the name of a data type to declare one. But it's not so obvious that the literal constants and the operators also have data types. And this is a key point. Operators only work on like-type operands. So if you have an int plus an int, then you're okay. You have 2 like-type operands. If you have an int plus a double, then you have a mixed type expression, and something has to happen before the plus sign will work. They have to be on the same data type operands. Okay, there's a lot of data on this screen, so this is going to be one of your reference points, this slide. So on the left-hand column, we have the 8 primitive data types in Java. I've drawn some bold lines in the middle. So the first 4 data types are all integer data types: byte, short, int, and long. And why do we need 4 different data types to store integer values? It's because each of these are different sizes. So byte, for example, is the smallest data type in Java. It takes 1 byte of space, and that means that since it has only 8 bits where it can store numbers, then the numbers can't be very large. So the range of values that you can put in a byte are minus 128 to positive 127. And then the the integer data types then get larger by doubling in size. So we have a 2-byte data type, a 4-byte, and an 8-byte data type. And the range of values, I started to express them in powers of 2 because this is the way that people usually remember them. So if you have 2 bytes of space, for example, in a short, then you can represent values that are in the range of minus 2 to the power of 15 to positive 2 to the power of 15 minus 1. And if you multiply that out, it's 32,768 on the negative side, up to 32,767 on the positive side. So you don't need to remember the exact decimal values, but you have to be able to calculate them. So knowing that a short takes 2 bytes of space, you have 16 bits in 2 bytes. One of the bits is used to represent whether the number is positive or negative. So you have 15 data bits that can be used to represent a number. And in int, you have 32 bits or 31 data bits. And in long, which is the largest data type for integer numbers, you have 63 data bits. If you look on the right-hand side of this, I'm showing how to represent constants that could fit into these integer numbers. So if you have a number that will fit into a byte, you can just assign it to a byte. If you have a number that is too big to fit into an int, then you have to represent it as a long, and you use an L at the end as a suffix for the number. So if you wanted to write this number in your Java program, you would have to put an L here to indicate that you want it to take up 8 bytes of space. Okay, the next two primitive data types are float and double. These are for numbers that have decimal points in them, and in Java it's assumed that you will use double unless you've got like millions of them and you need the memory usage to be smaller, and then you could possibly use a float data type. So in a float you have about 7 places of accuracy, and it doesn't matter where the decimal point is, but you have 7 significant digits in your number and an exponent that can go to plus or minus 38. So if you look at these numbers over here, 12.5f is a float literal constant, and you have to use an f at the end of the literal constant to indicate that it's a float. It can be upper or lowercase, it doesn't matter. Positive or negative numbers can go in there. And there's a mistake. This one does not have an f at the end, and that means that that literal constant is a double. So if there's no f, Java will assume that the literal constant is a double. So there's a typo. And double is the largest data type for storing numbers with decimal points, and you can move the decimal point 308 places in a double. It used to mean double precision, so there was a float variable data type and a double precision data type, and now the word double has been left over. You get twice as much memory and twice as much accuracy in the double variables. Okay, 2 more primitive data types in Java. One is called Boolean. Boolean data type is used to represent true or false. So if you have a Boolean variable, only one of 2 values can be in there, true or false, and these are the literal constants. And char, you can say char if you want to. A char is a 2-byte variable, and it's also a numeric data type. It's an integer data type, except it can't have any negative numbers in it. And the expected use for a char variable is to hold the representation of a character. So a literal constant that would be put in a char is a single character inside of single quotes. You can also use this /u if you want to actually put the number of the character inside of the char variable. Okay, well, I think it's about time that we went to the development environment and played with these a little bit. If you declare one of these for each of the data types, so let's make a byte, a short, an int, and a long, and I refuse to make a variable called lowercase l because it looks like a 1 and it just confuses people. So I'm going to call it al, a long, and here's a float, and here's a double, here's a Boolean, and here's a char. There are the 8 primitive data types with 1 variable of each of the primitive data types declared. Now I'm breaking the rule about variable names being correctly spelled English words. When we get to the place where we have problems that we're solving, actual programs that solve problems, then we won't have variables called b and s and so on. Okay, the literal constant 127, its data type is int, but it will fit in a byte. What would happen if I tried to put in 128? It immediately doesn't compile. The compiler can tell that the value 128 does not fit in a byte, and it won't allow you to use a literal constant that won't fit there. So the range of values, you can kind of experiment with it. Negative 128 will fit, but positive 128 will not fit. So there's the range up to 127. The same is true with short variables. If you try to put something in there that will not fit, it will complain about it. And I think that the range is 32,000 and something. So that one probably will not fit either, but that one will. Okay, so I don't have those memorized, the larger data types, exactly what the number is, but I know that if it's a short, It will hold up to 2 to the power of 15 minus 1 is the largest value, and if I need to know what that is, I could go and figure it out. So an int, notice that there are no commas in any of these literal constants that we're assigning to the variables. If you put a comma in there, it will not compile. If you write an integer constant that will not fit in an int in 4 bytes of space, then you need to add this constant L. I use a capital L because if you use a lowercase l, it looks very much like a 1, doesn't it? And you'll drive people crazy. So let's use a capital L as the suffix for our long literal constants. And now let's add a literal constant for a float. And this is one that surprises people. If you try to put 12.5 in a float variable, it doesn't work. We have to put an F there to indicate that this is a 4-byte value, and we can put it in of the float variable F, which has 4 bytes of space. Any number with a decimal point in it that does not have an F at the end is a double. There is a suffix D in Java, uppercase or lowercase d, but no one uses it because if you don't put it there, you have the same thing. So here's a Boolean variable called bool, and there's a literal constant true. You can put the value true inside of a Boolean variable, and only true or false. Okay, let's go back to the slides. I think it's important that you do some practicing in Eclipse and let it help you with the red squigglies and so on, so that you're really learning what the machine will accept, as opposed to doing it on paper or something like that when you might be making mistakes and there's no machine to help you. If you're looking at all these little light bulbs over here on the side, these are not errors, they're warnings. They're telling us that we've declared these variables but we haven't used them for anything. And that's helpful if you want to clean up your programs and get rid of the stuff that you've accidentally left in but didn't use for anything. But they're not helpful or harmful to us right now. Okay, let's talk a little bit about mixed type expressions, and you'll start to get the idea of why it's important that you know the order of the data types. So in the previous segment we talked about the difference between integer division and double division. So we were working with int and double, and remember that 10 divided by 3 is different from 10.0 divided by 3.0. So the operator has a data type. The divide in the first one has an int data type, and the divide in the second one has a double data type, and that means that the result of the division is also going to be different. So 10 divided by 3 in int is 3, and 10.0 divided by 3.0 is this 3.3 repeating number. So in a mixed type expression, suppose we had a double divided by an int. What would happen? The operator will only work on like data types. So which would the compiler choose? Would it choose to do it in int or double if we had one of each? Well, Java decides to promote. And how do you know which one would be promoted to what? If you have byte short, int, long, float, and double, if you had an int and a double, the int will get promoted to a double, and the operator would be double. Okay, so you have to know the order of these 6 data types so that you'll know when you look at an expression what will get promoted to what. There's no choice but to memorize this. So one of my students made up this beef stew is like food and drink to help you remember the order B, S, I, L, F, D. Memorize those now. Take a piece of paper and write down the 6 numeric data types in order, and then look at the screen again and see how many you got right, and keep doing that until you can write down those 6 data types in order. There isn't any way around it. You just have to know that. Okay, let's start looking at statements that use more than one data type. And we have to also be concerned with the data type of the operator when the operands are not the same. So these are all related issues. So in this code I've declared some variables of type int and type double, and Now I've written our first mixed type expression. An int is assigned to a double. Well, the assignment operator can only work on like data types. An int cannot be assigned to a double. So what happens is the variable value 10 is promoted to 10.0, and this is stored in a temporary location, and then 10.0 is assigned to double result. Notice that the value in A never becomes 10.0. A is an int, and it won't ever have a decimal point. So the promotion happens in a temporary location just for the purpose of evaluating this statement. Now look at this next one. We have a double D1 which has 4.5 being assigned to an int. What would happen there, if Java would allow that to happen, the 0.5 would be lost. Java is strictly typed. That means that you don't lose, well, one of the things that means is that you don't ever lose data unintentionally. And this one will not compile. So let's look at some statements that have arithmetic operators in them. We have result gets A divided by B. This is the easiest possible case. These are all integer or int variables. So we have 10 divided by 3, which is 3. And 3 is in the variable result. Now this is also easy. We have a double divided by a double, and the result is a double. And now we have one that has a mixed type expression. This has to evaluate to, we have a double divided by an int. One of them has to be promoted to the other. And since you have memorized the order, you know that int is smaller than double. So int would be promoted to double. 3 would become 3.0 for the purpose of doing this division. So we have 4.5 divided by 3.0, and the result of that division is a double, which will fit in a double. So this one will compile. I'm going into Eclipse now, and I commented out these previous ones so that our variable names wouldn't be duplicated. And this is the interesting part. This very simple assignment statement, and the error message is cannot convert double to int. So all of the rest of these are valid expressions because the value in B can be promoted to a double, and then the operator here has a double data type, the operator here has an int data type, and those are different operators even though they are the same symbol. I'll comment this one out so that our program will still be in a state where it can run. Okay, let's work with these a little bit more. This is the same case that we had before. It's just spelled out a little more. We have an int divided by a double. It doesn't matter which side, which operand is the one that needs to be promoted. We're going to promote the smaller to the larger. So int is promoted to the double 10.0 and stored in a temporary location, and then we have a double divided by a double resulting in a double, which can be assigned to this double variable. So Java will decide the type of the operator at the time the operator is evaluated. So this looks like a mixed type expression. We have a double on this side, and then we have an int divided by an int. So what is the data type of the divide in this case? It is in int. So it's decided at the time that operator is evaluated what is the data type of its operands. So we have an int divided by an int. The result is 3 of 10 divided by 3. And then for the assignment operator, the 3 is promoted to 3.0, and the assignment is done in double. Here we have the same variables, and we have another expression, and the question here is, what is the data type of the addition? If you look at a plus b, and you notice that a and b are both ints, your first answer might be that the data type of the addition is int, but it isn't. The type is determined at the time the operator is to execute, so the division happens first. We have an int divided by a double, which can't happen. We have to promote the int to a double. So this is a double division. The resultant data type is double, and then we have an int plus a double, which can't happen. So the int is promoted to a double, and the addition is also done in double. The result is a double, and the assignment is done in double. So you need to know the order of operation. If you have a float plus a double plus an int, what will be the resulting data type? Okay, now we're going to talk about typecasting. Java will promote the operands, or upcast, whenever it's possible. So if you have an int divided by a double, the int gets promoted to a double. Java will not demote or downcast implicitly. So if you have a double assigned to an int, we have a compiler error. But suppose we want the integer part of that variable stored in the int variable. You can do this explicitly in your code. So you can say, I really do want the integer part of that, the int part of that, assigned to this variable. So this is the cast operator. You put a data type inside of parentheses. It looks kind of like a declaration, but it isn't at all. For the purpose of evaluating this statement, the value that's in this variable is downcast to an int, and the result of that is assigned to the int variable. And a downcast is always a truncation. It's never a rounding. So if double variable had 1.9, the int part of that is 1. We already looked at this compiler error where we had a double literal constant assigned to a float, and it won't fit. Remember this one? We have a double assigned to an int, and if we want to, if we accept that the decimal point and everything after it is to be lost, we can downcast this so that we have an int assigned to an int. You can also, if you want to, although I don't know why you would, remember this one, that will not compile because we have a double assigned to a float, and our answer was to change it to a float by adding the suffix f. If you want to, you could downcast that to a float. So this looks kind of funny, but it indicates that you can change the data type of a literal constant, or you can change the data type of a variable for the purpose of evaluating an expression. Java will not downcast for you. If you want data to be lost, you have to use a cast operator to downcast your variables. Now, almost never have to upcast in Java, but in a few cases you do. So remember this one where we had 10 divided by 3. If we want that operation to happen in double, we really do want 10 divided by 3 to be 3.333. We can upcast the int a to be 10.0. So think about all of the things that happen in this expression. We have an upcast of a, that happens first. The cast operator has a higher precedence than the arithmetic operators. So this cast operator grabs onto what's on its immediate right and upcasts the value to 10.0, and now we have a double divided by an int. We can't do that, so the int is then promoted to double 3.0. Now we have a double divided by a double. So we almost never have to upcast in Java. The division operator is one place where sometimes you do need to. These arithmetic expressions can get complicated, and you have to be able to decipher them, including the cast operators and understanding the data types. So let's look at this big expression here. Well, this is the expression, and the whole thing ending in the semicolon is the statement. Okay, so what happens first? Inside the parentheses, a modulus b is 10 modulus 3, which evaluates to 1. Inside these parentheses, the downcast operator happens first. So we had 4.5, but now we have 4, and then multiplied by 10, we have 40, and everything is in integer now. Even though we had a double in here, it was downcast, so we have a 1 here, which is an int, a 40 here, which is an int. Let's do the multiply. 1 times b is 3. 3 plus 40 is 43. If it gets much more complicated than this, then the author of this statement should have thought of a better way of doing this. But you do have to be able to evaluate arithmetic expressions, including ones that have different data types and cast operators. Okay, there are a few more type issues that are specific to Java. We looked at the two smallest integer data types. They are byte and short. It is assumed that you won't be doing arithmetic with byte and short variables, and there are no operators defined for them. So there is no such thing as adding 2 bytes. But there is such a thing as adding 2 ints. So if you look at this statement here, b1 plus b2, adding 10 plus 6 doesn't seem like a very difficult thing to do. These are both promoted to int from byte. So we have 10 plus 6 in int, which is 16. And the problem with this statement is 16, the int value, cannot be assigned to a byte. So an int will not fit in a byte. And if the left-hand variable, the left-hand operand of the assignment, had been an int, then that would have been okay. So it looks like if we have int result gets b1 plus b2, that we're adding 2 byte variables, but we're really not. We have promoted those bytes to ints and we're adding an int. And the same rules apply for short. There are no arithmetic operators for byte or short. The Boolean data type doesn't play with any of the other data types. There is no Boolean cast operator because nothing can be cast to a Boolean, true or false, and a true or false value cannot be promoted to anything else. The data type char, or char, we said it's a numeric data type and it takes 2 bytes of space, but only positive values, so it has no sign. It's expected that the numbers in the char variables will be integer numbers that represent a character, and Java uses the Unicode character set for representing characters. But they don't have to be characters. They could be small numbers, and in that sense you could use a char variable in an arithmetic expression where the char variable gets promoted to an int. So in our list of numeric data types, including the order of promotion, we can add the char data type here, that a char will be promoted to an int for purpose of evaluating an expression. This is frowned upon. There are a few cases where it does make sense to use the numeric value in a char variable to require that it be promoted to an int, but not very many. But that's where it fits in the order of promotion. Okay, here are some practice exercises. I encourage you to go into the development environment, into Eclipse, and start playing with these, and make sure that you understand why each of these statements evaluate the way they do. The summary for this segment, I know it was long and I know it was boring. There isn't any way around getting a good foundation for the primitive data types in Java. There are only 8 of them. There aren't going to be any more. Java is strongly typed. That means that the variables and the literal constants and the operators all have a type, and operators in Java will only work on operands that are of like type. That might mean that one of the operands will have to be promoted so that the operator can work on 2 like type variables, but Java will not demote implicitly. So you have to use a cast operator if you want to demote one of your variables so that an operator will work. The choice of data types, when you're deciding your variable data types, it depends on whether you need character or a real number or integer number, and how large the values are. For numeric variables in Java, you're expected to use the data types int or double, unless you have a good reason not to. And a good reason really is you have a whole lot of them and you want to save some space by using one of the smaller types. Or if you have integer numbers that won't fit in an int, then you might need to go and use the long data type for your extremely large integer numbers. We looked at mixed type expressions, where the type of the operator is determined when that operator is to be executed, and the data type of the operator is determined by the type of the operands. Special issues in data types in Java: no arithmetic operators for byte and short, and you have to understand that typecasting doesn't change a variable. So if you promote an int to a double, that's only for the purpose of evaluating the current statement. It doesn't actually change the value that's in the variable. Boolean variables are very restrictive, only store the values true and false, and there is no Boolean cast operator, which means nothing can be promoted to a Boolean and a Boolean cannot be cast to any other data type. Okay, I think we have a very good basis now for using all of the primitive data types in Java, and I'm looking forward to getting to where we can solve some problems and write some interesting code.